Good morning.
Good morning.
Good morning.
All right, looks like we've got some extra students from Winslow again. So maybe you can ask me everything that you missed on the AZ Merit. No, I'm just kidding. All right, so all right. All right. So let's see. I guess let's take the roll, and then I've got several things I want to talk about before we get started today. Okay. All right. So let's see. Are all of my students there in Winslow?
Except Andrew and Junior.
Andrew and Junior. Thank you. Okay. So a couple of things here before we get started. I want to talk a little bit about extra credit. So today is extra credit day. So let's start with the course improvement survey. Okay. All right. So this is on the Moodle, and I just kind of want to show you where it is. Before, they have communication tools, learning resources, and right before the very first chapter that we started with, chapter 6, it'll say course improvement survey spring 2019. But right now it's hidden from you. It's not you're not going to see it. But I want to show you where it's going to be in the next, hopefully by class on Thursday. The only thing I'm waiting for is there's a way to make it so that you get extra credit for doing it. And so I want to give you like 5 points extra credit or something for doing that. So I'm going to configure that, but that's where it's going to be. So that's the first bit of extra credit. And so that's the one like you did last fall where it's just kind of point and click and you can make some comments, all right? So any questions on that part? Okay, so the second one is will be down in the final exam area. Let's see. This is the evaluation essay again. So like you did last semester, just kind of one wrinkle. Now, one big difference though between this extra credit and the other extra credit is this is extra credit actually on the final exam. So this, in a sense, is weighted more. So this is where you type up your evaluation and where you comment on anything in the course, the lectures, the teaching style, books, quizzes, tests. Let's see. Let's say the guided notes. Again, anything that you want to talk about, areas for improvement, the lecture notes, the videos. So tell me what I'm doing right, what you don't want me to change. If you were the teacher, what would you do differently? but please be realistic. And then kind of the extra question that was not on last semester's that I would like you to answer is, if you didn't get, maybe I'll even put that, if you didn't get the grade that you wanted, you were hoping for, what should you have done differently? Okay. Because maybe I can help future students, based on that. So I do want you to kind of respond to that. Now this, like I said, this little document here explaining everything is on the Moodle, and it's going to be in the final exam section. Okay. All right. So now you need to send this to me by email to my email address, jstrong@mpc.edu, and it's due Thursday, May 9th by midnight, because Friday is, let's see, I think it might be the 8th now that let's see. Thursday, no, we're good. So the 9th is good. Okay. So one full page, normal font, normal margins, double space, whatever. Okay. Now, I have had some people instead of sending me an evaluation essay, they'll send me a link to Google Docs. Okay, that's not what I want, and I don't have if I can't access it because I don't have your password or whatever, I'm not going to be able to give you extra credit. So I want you to write the essay and send it to me as an attachment. Now, if you have problems sending attachments from your email, then just write the essay in the body of the email, okay? But don't send me to a Google Docs or a Google Drive or something like that. Because sometimes I'm able to see it, sometimes I'm not. It just kind of depends on how you have set up your account. And so, anyway, all right. So, any questions on that? Yes.
Yeah, can we save it as like a PDF and send you
Sure.
like the PDF?
Sure. Yeah, no problem. So, yeah, you can send it as a PDF, just as an attachment for the email. So, no worries there. Okay. Any other questions on that? So we've got, a couple, 2.5 weeks or whatever for you to ask questions or whatever. But we'll, like I say, this is going to be posted in the final exam area. Okay, so speaking of the final exam, yesterday I made an executive decision in that the trig final I have always given 3 hours for. Okay. And so instead of, and I've never had anybody having any problems with being able to, run up against the clock or whatever. And so I kind of don't want to cut it down to 2 hours. So what I'm going to do is actually have the last 3 days be our final. And so I don't think it's going to take you an hour each day, but you're going to have the hour. So what we're looking at is May the 6th. What I'm hoping to do is do like a review on that day. So that's Monday. And then that will be my last broadcast. And then we'll take the final on the 7th, 8th, and the 9th. So you'll have 3 parts, an hour for each part. Okay? And then your overall final grade will be the average of those 3. All right, then, so the 5 points is not just 5 points on part 1 or whatever. The evaluation essay is 5 points on your overall score for your final exam. Okay? And I also will curve the final exam as well. So you'll get those points as well based on the highest score of all my trig classes. And I have 3. All right. Any questions as far as that goes?
How many questions are going to be on each test?
There's 20 questions on each part. Okay.
Is it going to be like last semester where you just did like the end chapter? So will we just do chapters 8, 9, and 11, or will it be over everything?
It will be over everything, but the emphasis will be since the midterm. But because, see, this is a little bit different in that trigonometry, the most of the trig stuff was actually in the early chapters. See, like what we're doing now with sequences and series, that's technically not trigonometry. So while yes, there is going to be an emphasis on the latter half, I am going to have, plenty of trig problems on there. So like, from finding the sine of pi fourths to doing an application, where you find the missing angle or the law of sines or law of cosine, any of that we did. Okay. All right. Anything else? Any concerns? Anything that I can help you with?
How many parts are there?
So there's going to be 3 parts that you'll do each day. So Tuesday the 7th will be part 1. Then Wednesday the 8th will be part 2, and then Thursday the 9th will be part 3. And each part will have 20 questions. Okay. Like I said, I've actually, as far as the trig final, I've never had a student say that they weren't able to finish or that there were some issues. Okay. The only thing I really worry about is, the technology. Like I remember last semester, somebody, the internet dropped. And I mean, that's the thing I worry about, but we can handle that. We'll figure it out if we run into any problems like that. All right. All right. Anything else?
No, thank you, Mr. Strong.
You bet. Okay, so now the last little bit of extra credit actually is from today. So today we're going to do 11.4, and I've decided to make this section extra credit. Okay, because you'll see when we get into it. So this section is going to be extra credit, which means that the quiz is going to be extra credit. And if there's questions on the final from this section, I'm going to make them extra credit too. Okay? Because it's a little bit different than what we've done. So let's just see. But so really, you have nothing to lose, everything to gain. Any points that you get from this section are going to be golden here. Okay, so this section is on mathematical induction. Okay. All right. So, and you do have guided notes for this, but it's a little bit different than what we've done in the past. All right. So, mathematical induction is kind of a form of logic. And I know you've all had geometry before, and you're probably missing, like, where are all the proofs that we did in geometry? How come we don't do proofs like that anymore? And I know you're kind of missing that. This is the closest that we come to really doing proofs like in geometry, but still, they're not really like the two column statements and reasons. They're not exactly like that, but this is kind of teaching you how to prove something using this form of logic called mathematical induction. Okay, so it's so the role of induction, mathematical induction, is most often used to prove statements about formulas and patterns. That's why it's really in this chapter in your book, is because what we've been dealing with is with sequences and series is all about formulas and patterns. And so we're going to use mathematical induction to prove some of those ideas. Okay? All right. So the first thing we want to do is kind of get used to the idea of following a pattern. Okay. Now, this says find the S of 100 if A sub n equals n times n plus 1 over 2. All right, so the A sub n, so the last term of this sequence is going to be the 100th term, so that's A sub 100. So using this formula, it's 100 times 101 divided by 2, which is 5,050. So that's A sub 100. Okay. Now, what we want to do is use this formula. Let's see. Okay. Okay, so this formula S of n let's see, wait a second. Actually, I've just realized that there's a problem with this formula here. So let's just do this. Why don't you find, okay, so we just found the 100th term of this sequence. So why don't you find the 200th term? So instead of finding the S of 100, I want you to find A sub 200. So the 200th term of this sequence. So just kind of plug into that formula. All right, so Cameron, what would be A sub 200?
20,100.
Okay, so A sub 200 would be 200 times 201 divided by 2, So that's 20,100. Is that what you said?
Yeah.
Okay. Any questions on that? Okay, so the first skill in being able to do these problems by mathematical induction is to be able to use formulas, just like that. So, okay, so check on that box. All right, next. All right, next I'm gonna show you the steps to using mathematical induction. All right, so the first step is whatever formula that we're given, we have to prove that it's true for n equals 1. So usually that's just making sure that it works for the first step. Step 2 is to assume the formula is true for n equals k. And then step 3, prove the formula true for k plus 1. Okay. Anybody need any more time on the screen? Okay. Okay. All right. So let me go to the next step. So when using mathematical induction to prove a summation formula, it is helpful to think of s of k plus 1 as the next sum. So the s of k, that's like the sum of the first k terms. And so then if we add in the next term, a sub k plus 1, then that's the sum of the k plus 1 terms. Now, if that seems a little confusing, then let me say it this way. So let's say s of 11 is the sum of the first 11 terms of a sequence. Well, that would be the same thing as the sum of the first 10 terms plus the 11th term. That would give us the sum of the first 11. Okay? So s of k plus sub k plus 1 equals s sub k plus a sub k plus 1. Right? So to apply the principle of mathematical induction, you need to be able to determine the statement p sub k plus 1 for a given statement p sub k. So this is kind of the next skill that we're going to need, is to be able to write the next term. Okay. Okay. All right. So here we have p sub k is the sum of k squared times k plus 1 squared over 4. Okay? So what we're going to do now is write the k plus 1 term. So what we do is everywhere there's a k, just replace it with k plus 1 and then simplify. All right? So k squared will become k plus 1 squared. And then k plus 1 will become k plus 1 quantity squared over 4. So the 4 doesn't change. You don't add 1 to that. All you do is everywhere there's a k, you just replace it with k plus 1. Now, this one you can simplify to k plus 2. But you really don't need to FOIL this out or anything. We're not worried about that. But if you have k plus 1 plus 1, just simplify that to k plus 2. And so that's all we're wanting here. Okay? All right, so see if you can do practice 2. All right, so Taylor, when you got it.
6 over k plus 1 times k plus 4.
That's it. Okay, so you replace the k's with k plus 1, and then if you simplify k plus 1 plus 3 to k plus 4, then that's it. Okay, great job. Any questions on that? Okay, so you have to be able to plug in formulas, and you have to be able to find the k plus 1 term. Okay, that's kind of your prerequisite skills here. All right, so now we're going to actually go through the steps. Okay, so the way that I like to think of this type of logic is it's kind of like if you've set up dominoes and you hit the first domino and then they all fall. Okay, so the idea is that when you prove that it's true for the first one, it's kind of like saying I can knock over the first domino. Okay, then you prove, and then you say, well, okay, assuming that I have a domino set up and it falls, then the next one falls. And so then by that logic, you knock over the first domino, and then if you prove that whatever domino you hit, the next one's going to fall too, then you've proved logically that all the dominoes are going to fall. Okay? So that's how I think about it. All right, so this says use mathematical induction to prove the following formula. So this says that S of n equals 1 plus 3 plus 5 plus 7 plus ... 2n minus 1 is equal to n squared. So whatever n is. So if you're going to add up the first 10 odd integers, then it'll be equal to 10 squared, or 100. Okay? So step 1. And so what you want to do when you're doing these is you're going to go through these 3 steps each time. So step 1 is we prove that it's true for n equals 1. Okay? So that's step 1. So when n equals 1, well, the first term over here is just 1. Over here, when you plug in 1 for n, you get 1 squared. So when n equals 1, so when n equals 1, you basically get 1 equals 1 squared, which is 1. Okay? So that's all I'm looking for. See, that's what I'm saying. In a way, they're a lot easier than a geometry proof. Because here for step 1, all I'm looking for is 1 equals 1. Okay? And you just proved it's true for the first term. All right, next. Step 2, you assume the formula is true and all you do is replace the n's in the formula with k's. Now you might see that's kind of a stupid step, but that's all you have to do. You're trying to prove, let's go back and see so I'm trying to prove this. So step 2, I just assume that this is equal to that, just replacing the n's with k's. So step 2 is also super easy. All the real work comes in step 3. Because in step 3, you're going to try to prove that it's true for the k plus 1 term. Okay? So this is step 3. On the left side, what we're going to do is add the next term, the k plus 1 term. So the next term, after 2k minus 1, the k plus 1 term is going to be 2 times k plus 1 minus 1. So this is the k plus 1 term that we're adding. So see this part in yellow is the same thing as this part in yellow. All I've added on the left side is the k plus 1 term. On the right side, you replace the k with k plus 1. So k squared will become k plus 1 squared. And so now the real proof comes from proving that this on the left is equal to this on the right. And so it's what we call an algebraic proof, where you're trying to show the left side equals the right side. So you don't really have to write down words that much. You're not writing a paragraph or anything like that. So it's an algebraic proof. Now, here's the next step is the tricky part. If you can understand what I'm doing in this next step, these will be easy for you. Okay? So in the next step, what we're going to do is see this part that's highlighted, that we assumed that this equals this, k squared. I'm going to replace all of this that's highlighted with k squared. And so all of this just becomes k squared. So now I have 2k squared plus, and then simplifying this, I get 2k plus 2 minus 1, or 2k plus 1. And then if I square this out, I get k squared plus 2k plus 1. So k squared plus 2k plus 1 equals k squared plus 2k plus 1. I'm done. That's it. That's the proof. Okay? All right. So now I'm going to leave this up and see if you can, because this is the step that's, the critical step. So just see if you can do practice 3A. So use mathematical induction to prove that formula. Let's see how far you get. Some of you might only get to step 1, some might get to step 2. You might do it all. Let's just see how far you go.
Did you say to do practice 3A?
Yes.
Because we don't have the notes here because...
Okay. Okay.
Thank you.
You bet. And I did put them all on the Moodle, so in case she's not there tomorrow or whatever, Thursday. All right, so Alana, what's step one?
I got lost.
Okay. So for step one, you just what did you put in your notes? What does it say in your notes to do for step one?
Yeah. Prove the formula. Time for n1, n equals 1.
For n equals 1. Okay? So the first term here on the left is just 5. Okay? So now plug in 1 for n and work this out. Simplify this. What would you get?
5.
5. Okay? So for step 1, what I would be looking for is 5 equals 5. Okay? 5 equals 1 times 1 plus 4, or 5 equals 5. That's step 1. All right, so Ellie, what's step 2?
So let's plug in k's for the n.
Yep. So you assume, and write the word assume, okay? Because you haven't proved this. You're assuming this is true. So you assume, and then you just replace the n's with k's. All right? Okay, so now, let's see, step 3. All right, Ellie?
So then you substitute the k plus 1 for all the k's. And
On the right.
On the right. Yeah.
And then on the left, what do you do?
You plug in, don't you move the k times k plus 4 over to where like all the numbers are and then add it?
No, not yet. You're not simplifying yet. Okay, so on this side you had right. You just replace the k's with k plus 1s. All right, but on this side, what you're going to do is add the next term. Add the k plus 1 term. So you're still going to have all of this plus one more term, which you get by replacing k with k plus 1. But so you're going to have, okay, so see, all of this is the same as this right here. Okay? And then you're going to add the k plus 1 term. So 3 plus 2 times k plus 1. And then on the right, you're going to replace the k with k plus 1. All right. Any questions on that? All right, so Taylor, I mentioned that the key step is coming up next. And what is that? What do we do next? Okay, you guys in Winslow in the back of the room, this is not an easy topic for these guys. So I need you to be quiet so they can concentrate, okay? Because this
They
is
are
not
quiet, Mr. Strong.
Well, I'm sorry?
They are quiet.
Well, I just saw them talking back there in the back.
You can't hear them. I'm sorry.
Okay. All right. That's fine. I just want my students to not have all the distractions. But thank you. Okay. So what's the next step here?
Prove the formula is true for k plus 1.
Yeah. So this right here, all of this, we're going to replace with what? All this that I've underlined here in green. And we're going to use this step 2. So all of this we're going to replace with what?
Is it k times k plus 4?
Yes, because all of this, we're in step 2 that we're assuming to be true. All of this is equal to this, k times k plus 4. So all of this that I've underlined, we're going to replace that with k times k plus 4. All right, so now I want you to do some algebra here and see if you can get both sides to be equal to each other. All right, Tiana, what'd you get? Did you get them to equal?
Yeah.
So what did you get on each side?
K plus 1 times k plus 5 equals k plus 1 times k plus 5.
Okay. So now what I did, and so the way how you did it is that you got them together and factored. What I did is I actually multiplied out each side. So here k times k plus 4 got me k squared plus 4k. And then combining here I got 2k plus 5. And then I FOILed this out and got k squared plus 5k plus 1k plus 5. And then combining like terms on each side, I got k squared plus 6k plus 5 equals k squared plus 6k plus 5. But if you're able to show that this is equal to this, that's okay. Whether you keep it in factored form or you FOIL it out or subtract the k squared from each side, however you do it, one side should be equal to the other. That's what we want. And that's the end. That's what we've got. So, all right. So any questions on that one? Okay. So we're going to go through one more here. Okay. Whoops. All right, so using mathematical induction, when proving a formula using mathematical induction, the only statement you need to verify is the first one, okay? That's the only one that you have to show works. So the piece of 1, or when n equals 1, yeah, that's your step 1. You don't have to plug in any other numbers, just the first one, okay? Okay, so now I'm going to use mathematical induction to prove that 1 squared plus 2 squared plus 3 squared plus 4 squared plus ... n squared is equal to n times n plus 1 times 2n plus 1 times 6. Now, before the days of calculators, see these little shortcuts to multiplying squares and cubes and all these little formulas that maybe aren't so significant now, they used to be huge. If you were like an accountant or did bookkeeping or any kind of business, that these were different ways, kind of nice tricks to multiply and so and add. And so these were very important back in the day. Now we just sort of use them to help us to do these proofs. All right, so if we start with step 1, so we're going to prove this is true for n equals 1. So the first term on this side is just 1 squared, which is 1. This now we have to plug in 1 here and see if it works. Okay? So we get 1 squared equals, okay, 1 times 1 plus 1 is 2. 2 plus 1 is 3 over 6. So this gives me 1 squared is 1. And then 6 divided by 6 is 1. So 1 equals 1. Okay? So that's step 1. All right, now step 2. We are going to assume that it's true for values of k. So just replace the n's with k's. All right, now step 3, where all the work is, now we're going to add, on the left, we're going to add the next term, k plus 1 term. So after k squared, now we're going to add k plus 1 squared. On the right, everywhere there's a k, I'm going to replace it with k plus 1. So I have k plus 1 plus 1 is k plus 2, and 2 times k plus 1 plus 1, all over 6. Okay, so now I'm going to replace the sum of these first k terms with what I assume to be true here in step 2. And so I'm going to get, so all of this that's underlined in red is going to become k times k plus 1 times 2k plus 1 over 6 plus the k plus 1 squared equals, and then I just simplified in here a little bit, 2k plus 2 plus 1 is 2k plus 3. So now I have to show this left side is equal to the right side. So now it's a little bit trickier algebra. But can anybody tell me a trick that I could use to make the algebra a little simpler? Maybe so I didn't have fractions? How can I clear out those fractions?
Multiply by 6.
Yes, multiply by the least common denominator, which is 6. So that's what I'm doing here. I'm multiplying this term by 6, this term by 6, and this term by 6. And so the trick there is to get rid of the denominator. So here, the 6's are going to cancel. Here, there's nothing to cancel, so it's just 6 times k plus 1 squared. And then here, the 6's cancel. All right? Any other ideas? So now it's simpler. There's no fractions, but it's still kind of rough algebraically. Does anyone see anything I could do to simplify before I started like foiling everything out? Is there anything I could do algebraically to simplify? All right, let me ask a more leading question. Does anyone see a term that is in all parts of this that I could maybe cancel out?
The k plus 1.
Yes. So since there's a k plus 1 in every term, it's like I can cancel that out. So you could think of it as factoring out and then canceling the k plus 1s, or you could just divide by k plus 1. However you want to think about it, the k plus 1 will simplify out. Then the rest of it we could go ahead and multiply out. So k times 2k plus 1 is 2k squared plus k plus 6k plus 6. And then if we FOIL this out, we get 2k squared plus 3k plus 4k is 7k plus 6. And then if I combine like terms here in the middle, 1k plus 6k is 7k. And so I get it to match. Okay? So you don't have to have it all multiplied out or simplified out even if you just have one side match the other. Okay, so I'm going to have you start on practice 3B, and we'll see how far you can get. Because this is extra credit, then what I'm going to do is just see if you want me to go over it on Thursday, I will. Otherwise, I'm just going to move on. Okay? But let's just see how far we can get together before we run out of time on this practice 3B. Okay? So go ahead and do step 1. Oh, here, I'll pop it up there for you guys. So you can at least write it down before you leave. So once again, the quiz on this section is just going to be extra credit. All right, so Shannon, what do you have for step 1?
Plug in ones in both equations.
And so what will you get when you simplify?
0.
You get 0 equals 0. That's right. So the first step, 1 times 1 minus 1, well, that's 1 times 0 is 0. Over here, you get 1 times 1 minus 1. Well, that's 0, so the whole thing's going to be 0. So 0 equals 0 is step 1. Okay? All right, and then step 2, what do you do? Anybody?